This says applying systems of equations. Honestly, the lesson is more about when I don't tell you what method to use, how do we pick which way is best? So we've learned three methods for solving systems of linear equations so far. Hopefully you know them. The first we learned was graphing. Sorry about that. That was where we would graph two lines, and then the point where they met was the solution to the equation. We also learned substitution and elimination. Now, honestly, it's not really easy to tell when graphing is going to be good. Most of the time at this level of math, we are going to give you answers that are whole numbers, in which case graphing can work fine in any of them. I'd say if they're in slope-intercept form or can quickly be in slope-intercept form, then graphing is usually a good choice. But the focus in this lesson is more on how can we, just by looking at the equations, decide whether we should use substitution or elimination. Now, that being said, this is an important thing to say. All systems of equations can be solved by any of the methods we've learned. It's not that sometimes this works and sometimes it doesn't, or sometimes this works and sometimes it doesn't. All of them work. We're really saying which one seems to be the simplest way to solve it given the equations we have. So, in general, graphing to solve systems is a better way to estimate the solutions, because while I said at this level of math we're most often going to have whole numbers, there will be times later in your math lives where plenty of solutions will be in fraction form or decimal form, and you can still get an estimate of the answer with graphing, but you won't be able to tell it as exactly. So the exact solutions are best found using substitution and elimination. So here comes the real question we do. How do we choose between solving by substitution, solving by elimination, only needing to add or subtract, or elimination that requires some multiplying before we add and subtract? So there are two things you need to focus on. The first is the form of the equations. Are they in standard form? Are they both in standard form or just one? Are they in slope-intercept form? And we also need to consider the coefficients. And so we'll explain that as we look at these. So I understand as you look at this giant list, you may think, this is daunting. How am I going to solve 9 problems? Well, we're not going to solve 9 problems right now. The goal here is to look for patterns and to see how do we know, just by looking at the type of equations they give, which one might be the best method. So I encourage you to pause the video, take time to look at each one of the columns, look at substitution only first, then look at the middle column, then look at the last column, and see what similarities you see among the three systems in each set. Okay, so let's remember we talked about different forms. So these, I do notice some slope-intercept form, but I notice some standard form too. So really, we do see different forms here. So the forms by itself doesn't tell us exactly whether substitution is good. But we do notice that in this one, y is by itself. In this one, y is by itself. And in the last one, it'd be pretty easy to get y by itself. Now, I'd happen to pick 3 where it was y by itself or easy to get by itself. It could just as easily be x by itself, or x is easy to get by itself. So the big key, I'd say, is at least one variable. Sometimes it could show up in both. But a variable shows up by itself with a coefficient of either 1 or -1. So I'm putting plus or minus 1 because it could be +1 or it could be -1, either way. So as you look at elimination, we're just adding or subtracting. So if you notice, every single example with elimination is in standard form. Then, if you look at the coefficients, at least one of the variables has the same coefficient. Now the signs might be different. I should have had a different sign somewhere in here, but even if this was a -9 and a +9, we still say same coefficient. +1a, +1a. -2y, -2y. So at least one set of variables, could be both sometimes, has the same coefficient. I could say the same absolute value because it's, whether they're the same sign or a different sign, all that does is determine whether we're going to add the equations together or subtract the equations. Either way, this method works well. So now, let's find the elimination where multiplication is required. So here, they're all in standard form again. So same form, and it's the standard form. And if you look, no two coefficients are the same here. Got a 2 and a 4, a 3 and a 7, a 6 and a 3, all different for the x's. 5 and 3, -1, -5, -5, +2. So no coefficients are the same. That's when it's best to decide, okay, what could I multiply in order to make one of them the same? So then I get add or subtract in order to eliminate one of the variables. So take one more minute, pause, and look and see if you see any type or style where it could be fine to use really either method. So here it is. When both equations are in standard form, and a variable has a coefficient of either +1 or -1, substitution and elimination are equally good. So after you have a second to write that down, I'd like to encourage you to look and see if you can find, there's actually, if I'm looking correctly, there's one system in each of these columns where that would apply. So pause it and see if you can figure out which systems in each column would fit in this category, where really substitution or elimination would work just fine. Okay, I'm going to put a star here, not an asterisk, but a star. This would be 1, because it wouldn't be too hard to get that y by itself and use substitution. This would be 1, because you could get either of these a's by itself and then solve by substitution, or just subtract the two equations and do elimination. And this one back here, I could multiply these two by 5 and then do elimination with that one. And the last one is here. So I can multiply the top equation by 5 and then subtract these two equations to do elimination. Or I could get this y by itself and then I could do substitution. So when you see ones in this category, it really is fine whatever you prefer. If you prefer substitution, do that. If you prefer elimination, do that instead. Because Because really, I would say there's no clear way to decide which one's easier or quicker. Okay, now let's practice this. So determine the best method to solve the system, then solve the system. So right away, well actually again, I would encourage you to pause and think about it for a second, see what you think is best. I think this is a scenario where you really could do either one. You could do, this is in that category where they're both in standard form, but one of them has a variable that just has a coefficient of 1. So I'm going to use substitution. But if you were to say elimination using multiplication, I would agree with you completely. It could really work either way, because I could multiply this whole equation by 4 to make those match, then I could add them together and eliminate the y's, or I could just add 8x to both sides and get y equals 19 plus 8x, or 8x plus 19, whichever way you prefer, and then substitute this in for the y in that equation. Okay, we got to distribute this 4. Make sure you apply the negative to it. So negative 4 times 19 is negative 76. Negative 4 times positive 8 is negative 32x. So 4x minus 32x gives me negative 28x. Then I'll add 76 to both sides. I get negative 28x equals 84. Then I divide both sides by negative 28. And I get x equals negative 3. So I have half my answer. I've got the x value. Now I can plug negative 3 into any one of these 3 equations to solve for y. I'm going to choose this one since it's already solved for y. I get y equals 19 plus 8 times negative 3. That's 19 plus negative 24. Which means y equals negative 5. So the solution is the ordered pair, negative 3, negative 5. And you would have gotten the exact same answer if you had solved this by doing elimination with multiplication. So this is an example of one where really 2 methods can work equally well, or equally quickly. Now number 2, pause, see what you think is the best method. Okay, here I would definitely say elimination is the better of the 2 methods, because these 2 have the same variables. We're both in standard form. I said same variable, sorry. These have the same coefficients. So I would say elimination using addition and subtraction. So when they have the same signs, I subtract the equations. So 5 minus a negative 2 is really 5 plus 2. Give me 7x. 7 minus 7 is 0. Those are eliminated. 2 minus 9 equals negative 7. Then I divide both sides by 7, and I get x equals negative 1. Okay, and I can plug negative 1 into either of these 2 equations. I'll just do the top one. 5 times negative 1 plus 7y equals 2. That's negative 5 plus 7y equals 2. Add 5 to both sides. I get 7y equals 7. Divide both sides by 7, and I get y equals 1. So the ordered pair that solves this system of equations is negative 1, positive 1. Okay, so pause for a second as I look at number 3 and see if you can figure out which method would be best in this case. Okay, they're both in standard form. That tells me to think elimination. And none of the variables are the same. Got 3 and 5 with x, negative 4 and 8 with y. So that means I'll need to do elimination where I start by multiplying. And to me, the easiest way is just double this top equation, because that'll get the 4 up to an 8. Now, there's other ways you could do it, but that's the method I'm choosing. So 2 times 3x is 6x. 2 times negative 4y is negative 8y. 2 times negative 10 is negative 20. Now, since these have different signs, I will add the two equations together. 5x plus 6x is 11x. 8 plus negative 8 is 0, so those are eliminated. Negative 2 plus negative 20 is negative 22. Then I divide both sides by 11, and I get x equals negative 2. And just a reminder, you can plug this negative 2 into any of these three equations you want, whatever you prefer. I'll just do the top one. 3 times negative 2 minus 4y equals negative 10. 3 times negative 2 is negative 6. I will add 6 to both sides. Get negative 4y equals negative 4. Divide both sides by negative 4, and I get y is equal to positive 1. So the ordered pair that solves this system of equation is negative 2, 1. Okay, pause for a moment. Look at number 4. See what method you think is best. Okay, this is another one in the category where I'd say you could do substitution, because you could just get that y by itself, or you could do elimination with multiplication, because you could just double this equation to make it worse so these cancel out. Since I chose substitution on number 1, I'll choose elimination on this one, but if you chose substitution, that's completely fine. So I'm going to double this top equation, because that'll make it so these two variables, their coefficients match. 2 times 5x is 10x. 2 times negative y is negative 2y. 2 times 17 is 34. Since they have different signs, we'll add the two equations together. 3x plus 10x is 13x. 2y plus negative 2y is 0. Those are eliminated. 5 plus 34 is 39. We divide both sides by 13, and we get x equals 3. You can plug in 3 into any one of these equations. I'll just plug in the top one, because that's how I roll. 5 times 3 minus y equals 17. 15 minus y equals 17. We subtract 15 from both sides, and we get negative y equals 2. Then we divide both sides by negative 1, or we can multiply both sides by negative 1. You get y equals negative 2. So our x value is 3. Our y value is negative 2. So our ordered pair, that's a positive 3. Positive 3 and negative 2. Let me just write it correctly. 3, negative 2. There we go. And that is our solution to that system of equations. I know this may seem silly because you're just doing the same stuff you did before, but in real life, whether it's math or not, there's often more than one way to solve a problem. And you're not always going to be told, solve it this way. You'll have to decide, okay, which method, there may be more than one method that will work, but which method is best and which method is quickest.